Someday I'll actually nail this intro right. Keep forgetting to take off the overlay right after the stream starts. Um, Hi everybody. It is morning over in the United States of America, so I don't imagine there's going to be a lot of people in my time zone. Feel free to drop in chat where you're tuning in from. I am very excited to talk about all the good things we're going to be doing today. But first off, I do need to acknowledge that I am, um, let's see, what's the word I'm trying to get at here? I'm still warming up and waking up to the day. So yeah. Anyway, I'm gonna go ahead and paste in chat a few handy dandy links. Well, I only have one actually. It's basically just going to be the link to our lovely. Ooh, let me change the layout. Oh, hang on. Okay, there we go. I'm gonna change this layout to this for now. Maybe do that. That. Okay, let's try this for now. Yeah, this is the link to the handy dandy check-in sheet. So if you haven't already, make sure you fill this thing out so that you can get credits for tuning into today's stream. If you don't know what I'm talking about, you check in and you get stickers for doing that. Now, as part of a new thing I'm going to be trying to do, let's see how long we can keep this up for. I have an unhealthy obsession with lettuce. And so I'm going to take like my daily lettuce snack bite before we get started on stream officially. So yeah, I hope you all are doing good and eating your vegetables. Got to stay healthy, you know. So yeah, I'll give you all a moment to kind of check in. We have a couple other links for you to check out, actually. If you want to follow along and read what it is we're doing, check out the textbook link right there. And if you want to follow along and code, check out this link right here. I'm going to make sure I actually sign in so that I can maintain my copy of these things on my account. Okay, without further ado, let's get into it. As a quick introduction, thank you. I appreciate it. I'm glad to be back and to be able to continue working on the nature of code. Before we get too far into it, I want to give you all a quick introduction to what the nature of code is and what language it is that we're using. The Nature of Code is a book that is written by Dan Schiffman. He's a guy who is a professor at NYU, I believe, somewhere in New York. And he does a lot of really awesome things around creative programming. And creative programming is something that I very much enjoy. He runs a channel that's called The Coding Train. Let me actually bring this channel up over here. So yeah, very fun guy, and his YouTube channel is very, I guess, like accessible to people who have experience and wants to build cool things, and also for people who don't have as much experience and still wants to build cool things. So that's the quick shout out there. Yeah, there we go. So this book in particular is a book on simulating natural systems with JavaScript, or technically just like with code, very generally. And so there's 11 chapters in total. I've done 2 streams on this, I guess like last month, where we covered randomness. Let's see how far we can get. Our goal is to try to, I guess like, do one stream for one chapter, but we'll see how far that goes. I took a peek at the vectors chapter, and it's a pretty beefy one. It's going to include a little bit of math, not math that we're going to be doing too much into because we have a computer, and we know that computers are pretty good at math, so we're going to be trying to lean into that as much as possible. Anyway, now let's talk about what P5 is. P5 is a library. It's a JavaScript animation library, and I'll show you and give you a quick tour of how this works in just a second. But yeah, it's really big for artists, designers, beginners, etc. I've run a class on this before, and I do not make nearly as many things as I should like to with P5. If you prefer to work with P5 and with like generative tooling, you could totally do that because it is just a JavaScript library. You can actually set it up on your local environment in VS Code, get access to Copilot and Gemini and all those other like good like LLM goodness things. We're going to be coding things entirely by hand because we're going to be doing it on the browser, and I think it's just more accessible to be doing it on the browser than setting up that tooling. In future streams, we might actually build like a full like project in it. I did do that before. I don't think I did it on stream though, and the tooling has changed since the last time I've done it. I don't remember what project. Oh, I was trying to do a thing that was based off of one of the chapters in this book before. And ended up getting really out of hand because I hadn't read the book in order. So this stream series is also like a good excuse for me to do that. And I'm happy to be able to bring you all along. So let's actually do a quick tour of what P5 looks like. So I have over here, if you go to editor.p5.js.org, which I will also paste in chat. Well, actually, I've already pasted it. I'm just going to highlight it right now. You'll end up on a screen that looks something like this. Now, if we start over on the things that kind of capture my attention, let's maybe just start with the top left bar. Thank you. I appreciate you for bringing in the link. The top bar is just kind of like our toolbar kind of thing. It's our usual help menus and stuff. If you need to change to a different language, you could totally do that. Let's change it to Dutch, for example. Yeah, it doesn't really change the code. I was really curious if it changed the keywords or not. Yeah, and then Sketch, if you need to add files, you could totally do that. I'll explain why you would need to add files in a little bit. And then we've got the file things to do all of the file management things. Yeah, there's a lot of really cool examples here if you want to just like poke around. Let's actually just poke around and check out like some of them. So this one says simulation. Simulations are generally pretty cool. Looks like this one's a snowflake. Yeah. So this is a fractal pattern. If you don't know what fractal patterns are, they're kind of fractional dimensions. I'm not going to dig too much into it right now because that I think actually might even have a chapter inside the book. It's a little beyond the scope of what we're going to be covering today. May cover it in the future after we finish the book. But yeah, anyway, lots of really cool things here. We'll notice next, I guess like from the top, we've got a play button. The play button just actually runs the code that you have right here, and then the stop button stops it. We've got auto refresh to make it so that if you're making changes to this thing like live, let's say we wanted to add in like a few more dimensions to the background, it'll just like run as soon as you stop talking, which can be good if you've got like more of a static image kind of thing going on. But since we're going to be working with simulations, sometimes it's really beefy on your computer. You don't really want the auto refresh happening. So I'm going to leave this thing off for now. And then we've got the name. I think forest cartwheel is a pretty funny one, but for the sake of keeping things sane inside my own like file management system, we're going to call this one GHW vector. And then I will just give it like whatever project number it is that we're working on, or like practice number, exercise number we're working on from the book. Okay, next up we've got the version number of our library. And I guess, I didn't know that it actually let us do library management. So we can actually just like toggle on and off the different, I guess, like add-ons that's bundled with P5.js. If there are any other like fancier libraries that you want to bring in, because like I said, this is just a JavaScript library, we can actually do that manually by popping into index.html and just like adding in some new script tags, which is pretty neat. And then next up, we've got the settings menu, which is just like, oh, I guess it's almost pretty much the same thing, just not on the library side. Okay, next up, I kind of cheated a little bit and jumped ahead. We've got this arrow, which basically just hides the sidebar. And this sidebar contains all of the rest of the files that we have in our website, or I guess like to build out this project. So you can see here we've got an index.html file, JavaScript, and CSS. So if we really wanted to, I think there's actually probably a way for us to just download this thing. Yeah. I don't know why it's not available right now. Usually we'd be able to download it. I mean, worst case scenario is that you could always just, you know, control all, control copy, and then I just like paste it into your own setup, into whatever it is that you want to work with. But for now, like I said, we're going to be doing things in here. There is actually a pretty handy, I guess like, there's this thing that's called ShiftBot. It's a Chrome extension. I wonder if it's public now. For a while, it was in kind of semi-open beta. Let's see. It looks like it's actually a public release now. So if you're using Chrome and you want to use this, absolutely go for it. It basically just puts a little helper bot that doesn't solve problems. It doesn't actually touch anything in the code. It just gives you recommendations on how to approach things and brings up relevant, I guess, like videos that Dan has previously done, which is pretty nice. I don't know that they have one for Firefox, which is what my browser is based off of. So probably not going to do that just yet. But if you want to check this out, I would be remiss to not give you the link. So yeah, there we go. Ba-ba-da-ba. Okay. Yeah. So I guess quick tour, code tour of what's going on with HTML We've got nothing crazy going on here inside the head. These are basically just scripts to let the library run, and then a basic CSS file to make sure that it fits to the screen. Just add some like I guess like CSS resets. And then we've got the body and a main elements tag. That main element tag is what the scripts, or I guess the library kind of anchors onto. So when we actually create something here, oh no, I'm sorry to hear that. Oh, I guess it's still very much like early access kind of like development. It's only got like 4 reviews even on the Chrome store. Yeah, hopefully they'll get some more support soon. But yeah, we're doing our part to make sure that there's some more visibility on P5, and hopefully that will allow them to speed up development on that. I don't actually know if it's Dan Schiffman who's doing the development on this, or if it's the Google team. I think it's mostly on Dan's part, and he's running his own streams for the coding train. I should actually plug his stuff a little bit more. I don't know that I'm allowed to share Discord links, so I'm not going to, but I will let you know that the coding train has its own Discord. So I believe if you just look it up, yeah, there you go. This is the official one. I'm in it, and he posts stream announcements all the time. So if you want a cooler educator, definitely check him out. He is my inspiration when it comes to these streams. Anyway, enough talking about that. Let's dive into this a little bit. Thing I wanted to point out is that the P5 library relies heavily on the canvas elements. I don't know if I'm going to be able to find it. Let's see if I just... Oh, it's not really showing up here. Okay, well, I'm going to hide that then. Basically, there's this canvas elements. So basically, the way that P5 works is it grabs or it creates a canvas elements and adds it to the main HTML elements tag. So it's somewhere like right in here, and then it adds like a few other goodies to it. We're not going to do that manually because then we're going to break things. But yeah, that's very generally how P5 works. If you need access to the console for whatever reason, especially for debugging or planning, it is accessible right down here. Sometimes it's hidden like that. And you'll also notice that when the screen is kind of like halved like this, it it just shows like the one screen. And then so if you want to see the output, you'll need to do that. I'm actually going to zoom out a little bit just so that we can actually see the preview and the code at the same time. Unfortunately, there's not a way to update that necessarily. I see you're using Zen. That is correct. I am using Zen. Zen is, if you don't know, a pretty cool browser. um, Basically, it's like, I guess if you're following the browser space, you'll know that Arc browser exists. And they're one of the ones that I guess like pioneered the whole sidebar thing. Um, Actually, I found this setting in Edge, Microsoft Edge, I think before I saw and learned that Arc existed. But one of the other things that they're really well known for is they have these like access to workspaces. This is something that Firefox has actually had for a while. Firefox has containers. I'm not going to open mine up because I don't remember what it is that I last like opened there, so I don't really want to dox that. um, but yeah, Firefox has these things that are called container tabs, which basically allows you to have like different, I guess like browser profiles, kind of like in Chrome. You can log in with an account, and then all of your bookmarks will be saved to that account, kind of deal, and like all of their like search history and stuff is going to be attached to that profile. In Firefox's ecosystem, there's this thing that's called containers, which does the exact same thing, and so Zen takes advantage of that. So I've just got 3 containers. I've got one for personal, I've got one for university, and I've got one for let's see, what's it called? MLH, and also other personal things. But yeah, very cool browser. I do recommend. It is a bit weird on my Linux setup because, let's see, I think my my install is just kind of bugged. There's like a graphics problem with Firefox on my Pop OS installation. Completely unrelated. Anyway, yeah, glancing feature is really nice, and the clutter, oh, it's so crispy. I actually have confused a few people because of how much like the sidebars just kind of kept popping in and out. And because of like how minimal it is, it kind of looks like it's almost like native apps, which is pretty cool. Um, yeah, I'm a big fan of keeping a clean kind of like desktop. Let's see if I actually have. Yeah, there we go. Like I don't like having anything on my desktop at all. And so this kind of helps me maintain that aesthetic. Unfortunately, I've got like too many freaking things in this top bar. I don't actually even use Alfred. The Spotlight feature Mac like works by itself totally. I actually need to uninstall this Arduino Cloud Agent because I don't use that anymore. Anyway, that is a bit of a side tangent if there ever was one. Okay, let's actually start getting into it. I'm glad I'm not alone in the desktop clutter space things. I imagine I'm also not alone as far as like keeping my file management clean. I am a little bit behind on keeping all of my PDFs outside of my downloads folder. My downloads folder's a lot beefier than it should be right now. I wonder how much. Let's see. I'm gonna show this off screen. Okay, that's not too bad. I've only got like 1.4 gigs inside my downloads folder, so that's not bad. But I've got like probably like 100 different files in there, so I'll need to clean that up. That is a off-stream problem though. Okay, so let's get into the actual thing. Let's see. I was given some feedback that we're not actually going to be looking too much into, I guess, like reading on stream anymore. So what I'm going to do is I'm going to, I guess, like kind of read just the important parts of the stream. Okay, so let's see. It opens with a strong thumbnail of some stick art and even stronger quotes, this very same quotes that I posted. I guess I posted a little bit more. Very iconic quotes from Despicable Me, which is a 2010 like animated movie. Very relevant reference there. So I guess sticks have been used for a long time to help with navigation. I can see how that's kind of very fitting for a chapter on vectors. And it is talking about, let's see. Ah, here it is. An abstract representation of vectors that captures the ocean patterns and directional flow. That is honestly really cool. I was actually just reading a paper on, I guess, like indigenous practices earlier, but that is related to my class and not to the stream. So we're going to continue talking about stream things. Okay. This book is all about looking at the world around us and how to simulate it with code. This is kind of like the first official chapter. Even though it's haha computer science joke, we start at index 0. The very first chapter, I guess, like isn't as. It's more of a setup for the rest of the book, which is why it kind of, I guess, like starts off with another first part kind of deal. Everything covered within the first 5 chapters requires the use of the most basic building block of programming, the vector. That's where the story begins. I guess let's actually take a quick peek at what the first 5 chapters are. Vectors, forces, oscillation, particle systems, and then autonomous agents. I don't know if autonomous agents is included in this. We'll see, I guess, in about 5 GHWs from now. Depending on how many streams we can get in before then. But yeah, vectors can mean a lot of things. In C++, it is actually the same thing as a data structure. I am actually really curious about what the etymological, I guess, like, origins are for C++ being called vectors. Am I good in maths? Maybe in middle school. I would say I'm not a very strong person in maths. Literally, I think yesterday, actually, I was doing. Sorry, this is a bit of a side story. I was doing, or I am taking a class in game design right now. And in that game design class, we were working on finalizing our one-page RPGs. I don't have anything I can show just yet for that, not publicly, because we haven't published on itch yet. If you don't know what itch is, it is a place for, I guess, like indie developers to post their games that can be both, I guess, like role-playing games that are analog, which means like offline, which means like papers and PDFs and stuff. And then there's also like indie video games there as well. And we ran into a problem of balancing our difficulty because we were doing a lot of things with cards. And we made it so that you needed to collect X amount of cards in a certain pattern in order for you to succeed. But we initially made it too difficult because we didn't do enough playtesting and we didn't have enough like mathematical intuition to realize how long it would take for us to actually achieve those patterns with the rate at which the players were picking up cards. And so I was like, hang on a second. I know there's a mathematical way to prove these things. And then the more I thought about it, the more my brain hurt. And then I got to the stage where I just asked chat what kind of math I should be doing. And then I realized I can do one better. I'm just going to ask chat, what is the probability of X happening X? And then, yeah, basically I didn't do any math and we ended up just like freeballing and reducing the difficulty to just be to err on the side of easy, just so that we could finish the assignment. That is a really long-winded way of saying no, I'm not excellent at math, but we're gonna see how far we can get. This book is generally a pretty accessible book, so I don't imagine the math is gonna get too gnarly. We shall see. Yeah, so if anybody else in the crowd struggles in math like we do, like I do, we're all in this together. If there's anybody in the crowd that is good at math, please feel free to hop in and help me. I need to take some remedial math classes. And that is somebody speaking as And that's coming from somebody who's graduated undergrad 2 years ago and is currently in grad school. Um, anyway, let's get into it some more, or let's continue. Let's see. We are talking about Euclidean vectors, also known as geometric vectors, which is both magnitude and direction. There's the famous quote again. Vectors are typically drawn with an arrow and the direction that they're going. And we've got this handy dandy YouTube video that explains what vectors are and has a wonderful, I guess, like simulation in the background. That is actually a really cool flow simulation thing that's in the thumbnail for this video. I don't know that we'll actually get to that inside this chapter, but let's see how far we can get. If you watched any P5 beginner tutorials, it will probably talk about the bouncing ball sketch. Okay, so apparently this is a very iconic one. Let's actually switch back over to a more normal, just like canvas setup. This is the thing where all of our code is going to live. If you weren't here for the previous streams, in chapter 0, we talked a little bit about how to, I guess, like build more scalable, I guess, like architecture for when it comes to creative coding, which is pretty nice. In the sense of, I guess, like building with classes and objects and JavaScript organizational structures very generally. I see somebody waving in the crowd. Hi. Thanks for the wave. Oh gosh, that lost my train of thought. Oh yeah, so class structures and stuff. I don't know that we'll be jumping into doing that. It looks like we can actually just do everything inside our main function right now. So let's go ahead and build this out together. I'm gonna be coding things by hand just to make sure my muscle memory stays good. So looks like, oh, actually these variables, oh my word. What happens? Oh, that is so strange. I've never done that before. So what happened was I've accidentally flipped this from right sides to left side, and I've never seen that before. Okay, good thing is we could just refresh that page, and we are there. Somebody making a comment on math. I thought I was good at math until I met somebody great at math. Yeah, people who are good at things kind of humble you very quickly. I had some crazy imposter syndrome when I went to university. And I knew it was going to be really bad because I came from a really small high school, so I wasn't really good at a lot of things. I was good for my school, which was like very, very mediocre / okay by everybody else's standards. So I kind of got absolutely floored when I went to my undergrad. But yeah, my roommate in my freshman year was an aerospace major, and he was like really good at math. He didn't do math competitions. That was another one of my other roommates. He did actual math competitions, and it's like, oh, I wonder who's going to be better at math. But that was very much an inside thought. Okay, thankfully we have computers, and computers are much better at math than I am. So we're going to be leaning on the computer to do a lot of math. But let's get into actually typing things. First thing we're going to be doing is we're going to be tossing in our variables at the very top, and we may be getting some small warning signs, I guess, because we haven't actually used these variables anywhere. So I guess something that's very common pattern inside game dev and in animation, or just like any sort of creative coding, is we usually have some sort of x, y, and then x other kind of variable and y other kind of variable. There's a few different ways to organize this. One way is, I guess, like organizing it into like an enum enumeration or like some sort of objects. I don't think we're going to be getting complicated enough to the stage where we need that, so just using separate variables for now is totally fine, especially since Or I guess I don't know why I'm even bringing that up. That's not even relevant right now. We should do more like just in time kind of math. Okay, so what's going on here in this bit is we are basically just like adding in the I guess okay. So the way that we can think about the way P5 works is very similar to traditional animation, where if you draw on a piece of paper, right? Actually, I wonder. Let me actually just bring out a thing. I'm gonna bring out this whiteboard. I like to sign in so I can make sure I keep all of my things. Okay, so we've got a whiteboard, right? Let's say we've got a few animation frames. So we start with like a circle here, and then these other frames are going to have the same circle, but maybe they'll move the circle a little bit here, and then maybe over here the circle will be moved a lot more over here, right? And so basically, in order for us to do like any sort of animation here, we're kind of, I guess, like just taking the difference between where this circle is relative to the rest of this canvas and where this circle is relative to, I guess, like where this was. And so the difference between these two right here is just going to be the difference of speed. And so that's what it is that we are doing right over here. We're taking the previous position and then just adding the speed to it to make it move that far. I'm also realizing that this should have been inside the draw function. Okay. So a few quick things here is, I guess I should have mentioned this earlier. We've got two functions by default inside the main, I guess, sketch.js. That is setup and draw. Setup is a function that runs once at the very beginning. So if you're familiar with Arduino code, it's something similar. I think it's actually named the same thing inside Arduino. It's also a very common pattern inside game development as well, where there's some sort of like setup thing, and then there's something that runs constantly forever and ever. And that's what this draw loop is. And so this thing is constantly drawing all over the place. And so if we want something to happen that consistently happens like constantly, then we'll want to be tossing it into our draw function. And so that's what it is that we're doing here. But obviously for like a variable declaration, we don't need to be redeclaring these specific variables all the time. Otherwise, like it would always be starting at the very beginning. And so what we're doing is we're actually just setting that once right at the very beginning. Ah, I see a question. Sorry I missed it earlier. I was a topper student during my college days. I was most definitely not. I was actually a pretty below average computer science student in many ways. And for many reasons. I was honestly not a really good student. I didn't go to a lot of lectures, especially in my junior, senior year. I guess to illustrate that, I should mention that. Hang on, let me write it as a code comment just so I can illustrate this better. I graduated high school in 2019, and then so I started college in 2019, fall 2019. And so I had about 10 weeks of school, so one full quarter, and then 1.5 quarters by the time that COVID happened, and then everything kind of got shut down, and we all got kicked out of university being on site. So then COVID happens around, let's see, actually, wait. Did I have my first quarter? I'm pretty sure I did. So then I guess like COVID started around fall 2019, but then the quarantine didn't start until 2020 of winter. And so this is when I got kicked out. Up until then, I was like a pretty good student. I was going to every lecture. and doing math. And I was even going to supplemental instruction, is what my university called it, and like tutoring, just so I could get like good enough at math. Because like I thought like doing the homework was going to prepare me for the exams. It did not, in fact. And then when quarantine happened, I was not a very good student. I missed a lot of lectures and was barely holding on to my sanity. And then we came back to university in around, I guess, like returned to campus around 2021. And then I continued that habit of not going to very many lectures. So if any of my professors see this in the future, I'm sorry I didn't go to your lectures. I started doing a lot of club work. And so that's why I ended up skipping a lot of lectures. But that club work is the reason why I'm here today, because I was doing work in computer science education. And that is the kind of stuff that I'm studying now in grad school. Wow, I get derailed a little bit easily, but I appreciate the questions. Okay, let's keep on going. So we know that we're going to be adjusting the speed, I guess like every frame. And so I guess I should also mention that this draw thing updates every frame, and I believe it runs at like, actually I shouldn't make a guess. Let's see how fast P5 updates. P5, JS, FPS. Oh, okay, so we can actually change this. It looks like the default is most computers default to 60 FPS. Frame rates are generally 24 FPS. I don't know what the default is. Okay, so it's either 30, 60, or 20 FPS, or yeah, 24 FPS. At this stage, I can't really tell from this documentation. Maybe, oh, this thing actually tells you what the default is, I think. Frame rates, display the current frame rates. If the mouse is pressed, do lots of math to slow down the drawing. I'm clicking my mouse if you can't hear that, and nothing's really happening. So it looks like, I'd say the default is about 60 FPS. Okay, so yeah, this thing runs once for every 60 FPS, blah, 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 blah. Let's actually get to copying the rest of this. Okay, so this is just a bounds check to make sure that it stays within the screen. Okay, cool. So now we have a bounds check, and then finally we need to actually draw the ball. So we're going to start with declaring the stroke, making it something that we can see, and then circle X, Y, and 48. Okay, so I'm going to run this thing just to make sure it works, and then I'm going to describe real quick what's going on over here. This stroke is a function that's specific to P5, and basically just says, like, I'm going to be adding an outline to whatever shape it is that you're going to be drawing. And so in this case, that's the reason why we have, hang on, this kind of distracting. That's the reason why we have this black outline. That's what the stroke is. So if we wanted to make the stroke thicker, like 10 pixels. Oh, sorry, that's not thicker. This is actually controlling the color of the stroke. If we wanted to make this thing like white, for example, we could change it all the way to 255. And there it is. I think there's, I don't remember what the P5 thing is, but we can pop over here and take a look into the reference and grab the stroke weight. Okay, so if we wanted to make it a thicker stroke weight, we can do that. This thing, now this would make it a rather thick circle. Okay, fantastic question. Which one is more helpful for learning coding? YouTube tutorials or reading documentations? What do you think about this? I think that the thing that will make you learn the fastest is building projects. And so whichever one helps you do that. There's actually this really cool paper on scaffolding creativity. Let me see if I can bring it up. Let's see. I'm going to bring this up off screen because it's something that I need to pull up from my email. So don't mind me doing that. But basically, it recommends doing things, or I guess it shows you how much work and classifies the different, I guess, like quadrants of creativity and I guess like technical ability. I'm not explaining it very well. Let me actually just bring it up real quick. Okay, here we go. This is me citing my sources because I am a good grad student. Let me actually share this link over here. So, this paper talks a little bit about the cognitive load and I guess like the pros cons of these 4 different ways of building projects. And I think this is applicable to both programming as well as creative projects. Basically, on the left side, we have, I guess, like how you're doing something, and then we have whether the thing that you're making is the same or different from what it is that you're working on. And so we've got something that's like a Lego instruction set, which is where you're following an explicit tutorial. This may be doing something like following along to this stream or following along to YouTube videos or building like tutorial projects. And I definitely recommend you start here instead of diving into the documentation, because the documentation is more useful when you have enough of an understanding to learn how these kind of like Lego blocks kind of fit together. Because up until then, you're kind of just like trying to figure out like what the Lego block is and what it is capable of doing. There's this thing inside the field of human-centered interaction, which is actually design of everyday things. Summary. Let's see if we can pull up a summary of this thing. There are 2 really big things. Let's see if we can find it. Affordances. Okay, so affordances are these things that is basically what an object is capable of doing. And then there's these things that are called, I forget what it's called. Yeah, possible interactions between an object and its user. Signifiers. So signifiers is the other big word here. If there's anything that you pick up from, can do from the world of design, it is to pick up what an affordance is and what a signifier is. Signifiers are what it looks like something can do, and affordances are what things you can actually do. If nothing else, this book is a very interesting read. But yeah, so basically, being able to follow a tutorial helps you figure out what the affordances of different techniques and libraries and tooling, etc., how things work together beyond just the signifiers, unless the thing that you're working with is really good at writing signifiers, which is not necessarily the case for libraries in general. So if you want to learn coding, you need to learn what the affordances of I guess like all of the functions that you're working with. Okay, so this over here, this category right here, is if you're planning on rebuilding an existing project, but you're doing it without following instructions. So this is reverse engineering. So this is like making like a Twitter clone or like a Twitch clone, which are very ambitious projects. I wouldn't recommend doing those specific examples. But it's more like if you observe something that's been done before and you just want to make it yourself. And then over here, this is modding. So if you're into video game mods at all, this is changing existing functionality inside of something else and not necessarily improving, just like changing things around. And obviously, the extent to which you change something is going to vary. But I think this paper says that modding and recoding have a very similar, I guess, like cognitive load as far as difficulty goes. When I say cognitive load, I'm talking about the amount of things that you can think about at any given time and the amount of things that you can kind of like do. So if you're doing something that's new, you're generally going to be under more cognitive load. In other words, like I guess you're going to be thinking really hard if you're doing something new. Whereas if you're doing something that you're familiar with, you're going to be, because you've done it before, there's already existing patterns in your brain, in your neurons, that make it easier to, I guess, like do, since they're repeat patterns. Finally, there's architecting, which is more around the time where you would actually really need to use the documentation. This is where you build your own project entirely. So yeah, anyway, I hope that helps your question on, I guess, like learning coding better. The other really big ways, I guess, you could just like hang out with us on stream. Boo, boo, boo. Okay, so let's get back into it. You've actually ordered the design of everyday things. It has not been delivered yet, but you're waiting for this book. That is awesome to hear. It is a really fantastic starting place. When I started my design program at my university, this is the book that our entire first class was talking about. And mind you, I only took 3 dedicated design classes, and this was one of the 3 that I needed if I was going to get my minor in design, which I was really close to, but I was 2 units short. So I'm short of a minor on a technicality, which I'm really bummed about. But it is what it is. Yeah, it is a really good book. It also helps that my university was the host university for the guy who wrote that book. He's still around and kicking. He's a very iconic man, Don Norman. He wears this like flat cap wherever he shows up. He's not as tall as you might think he is, which is a weird thing to bring up. But that's enough about that. Let's get back into what it is we were doing here. So I was showing you what all of these different things are. Fill is basically just like the fill color of whatever it is that we're looking at. So you don't really want this ugly like gray. Sorry, it's not ugly. Every color has its place in the world. So we're gonna make some worse colors. We're gonna make this kind of greenish color. I'm not actually a big fan of that. I want something that's a little more muted. Let's see if... Nope, that did not help at all. Let's reduce that. Maybe like 100. We'll maybe do 150. Okay, now we've got like a collard green on top of like a mustard green thing going on. I'm not a huge fan of my color choices, but that's okay. Okay. Another thing you'll notice here is that this circle is kind of bouncing off the middle. That's because circles are drawn from the middle going outward. So it's just something to keep in mind there. We've got X and Y over here. So X is the X position where it is relative on this canvas, and Y is the other position. And then this last number is the radius, which is how big the circle is. These are kind of like magic-y numbers, but that's okay because this is a small project, so we don't need to worry too much about, I guess, like being able to remember what these numbers are later. But not every shape is drawn from the middle going outwards. If we were to instead replace this thing with a rectangle, which we can do something like this, and then actually this is actually going to draw a square instead. You'll notice that it actually bounces off of this top left corner. So point of origin is relevant here. And I guess one more thing that's relevant to P5, or I guess not necessarily P5 in particular, but just like animations on computers in general, is that the XY coordinates are a little bit different than what you might be used to. So usually we've got a thing going on that looks something like this. This is a very rough thing. Whereas X gets... Oh, wow, I have those things swapped. Okay. whereas x gets bigger, it goes to the right, and where y gets bigger, it goes to the left. But in P5 and in other animation things, this is actually flipped. The y direction is, at least. And the reason why is because when we scroll websites, which direction do we scroll? We scroll from the top going down. And so instead of building from the bottom up like we're used to with normal coordinate systems, we need to go the other way. It's kind of like if you're writing like a scroll, or I guess like a normal docs thing, you generally start from the top and go down. So that's just something useful to keep in mind. I don't know that we're going to be having to deal with this explicitly, but we'll see. Okay, so let's go back to using our circle over here. By the way, the control / or command / on code snippets still works here, which is very handy. I just behaved like a typical developer. What does that mean? Are you saying that you can smell me and that I haven't showered this morning yet? That's fair. I kind of just woke up like not that long ago. Well, actually, no. I woke up like 2 hours before the stream so I could do some other homework, which I haven't finished in time. Little awkward. Anyway, that's me being a bad student. Feel free to elaborate on that statement. I'm very eager to hear what you have to say about me being a developer, a standard developer. You just it's about stroke efficiency, people. We don't get rid of things unless like you are absolutely sure you were never going to use it again. The other thing was I was actually really impressed with how beautiful this Y was compared to my X. Like this X, I wouldn't have minded if I deleted it because like I feel like I can draw a better X. That looks. I think that looks better. I like the little handwriting this. But yeah, it's really funny about the whole developer thing because in the grad school that I'm at, I don't have too many other developers in my classes, and so it's weird realizing that I'm no longer surrounded by developers like I was in my undergrad. All right, let's keep moving in this thing. We are like an hour in, and this is how far we are in the book. I don't think we're gonna be able to finish this today. Well, let's hope we can finish it by the end of our second stream. If you don't know, we are running the stream again tomorrow at almost the same time. We're gonna be starting an hour earlier tomorrow. But yeah, okay. So he goes ahead and explains what all of these things are. It looks like we're actually going to be adding. I was gonna say he might be adding in acceleration. It doesn't look like it. It looks like he's just mentioning that it can exist. Let's see if there is a thing describing or setting up acceleration. Nope, this is just all of the math parts. Okay, so let's start digging into the math bits. We're going to be going through the lens of somebody who's not a math major. Let's see how far we can get. So we got acceleration, target position, which is where we're planning on going, wind direction, which I'm assuming is going to be very useful later on. Okay, so here he just explains that we're looking at in a more sophisticated sketch, we may add more variables that affect the x and y, like how much things are being pushed, how much things are being slowed, and the rate at which they're changing speed, and then adding in another dimension. All right. Start with a thing like this. Thinking of the ball's properties as vectors instead of a loose collection of separate values will allow us to be more concise. All right. Taking this first step towards using vectors won't let us to do anything new to magically turn our sketch into a physics sim, but it will help us organize code. Big fan of being able to organize code. That is a really big thing in, I guess, like just general documentation and writing clean code, being able to organize it. All right, cool. So vectors allow for 3 dimensions, but we're probably only going to be using 2, so I'm pretty sure it will allow us to just do 2. Shows us some vectors and possible interpretations. Boop, 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 boop. Yep, allows us to basically go diagonally, which is nice. So we can think of a vector of -15 as going to the west. It's 3 steps north. I imagine he's going to also talk about the thing that we had just talked about with the y direction being down instead of up. For every frame of animation, you instruct each object to reposition itself to a new spot of pixels. This is pretty much a vector because it has direction and magnitude. Wonderful. Okay, so the vector sets the velocity, which is the rate of change in respect to time. Very cool. And we all know that acceleration is the rate of change of velocity. So that tells us how fast we are changing our velocity. Oh, I guess we didn't necessarily know that, but I'm just adding that in because otherwise I'm going to forget about that if I don't say it out loud. Okay, so there's this basic algorithm for motion. The new position is equal to the result of applying velocity to the current position. So, and the way that we did that here is by just adding in the speed. So the speed here is basically the same as velocity. But I guess like speed doesn't necessarily have direction. It only has magnitude, which is how fast, and then velocity gives a direction. All right. Velocity is a vector, then what about its position? Is that a vector too? And then he says that you could argue that it's not a vector because it's not describing how to move, it's describing a single point. I would even argue that it kind of is, it just has a magnitude of 0. As in, like, not knowing that it's not moving is still, I guess, like, relevant information to me at least. Nevertheless, another way to describe a position is as the path taken from the original points to the origin points to the current point. All right, cool. There's our bouncing ball. This is translating the compass directions into the directions that we have to work with for our canvas. Let's examine the underlying data for both position and velocity. Recently had the following variables. Yes, we did x, y, and speed. If we were to write a vector class ourselves, we would do something like this, where we use a class and a constructor to define, I guess, like the properties x and y. But the nice thing is that it already comes with one, so we don't need to do it ourselves. And instead of writing it in a bunch of different things, we're going to be putting it into a class. So let's go ahead and do that. We're going to chop, chop, chop. Be gone, numbers. We're going to set this to be create vector 100, 100. And so this should be the starting point. Since our canvas is 400 by 400, that means we should be kind of like in the upper quadrants. And around here-ish, I would say, is where the starting point is. And then we're going to have, excuse me, the velocity be create vector 1 and 3.3. So it seems like these vectors are basically just giving us positions, and then I'm guessing we're going to need to do something to make sure that it goes from one position to another. These aren't objects that we expect from calling a constructor function, which is the thing that makes a copy using whatever blueprint it is that we're looking at. Instead of writing new vector, we've called create vector, which is a helper function to help us set up an actual one. Okay. Except in special circumstances, we should always create vector objects with the thing creates vector. That is probably because this function's underlying implementation is adding in some more data, like information kind of things, than just giving it the, I guess, like positions that we're looking at. I should note that P5 functions can't be executed outside of setup or draw since the library won't be loaded. Okay, well, that's good to note. I guess that means we will probably need to move this inside here. The problem with putting inside setup is that this is a different function from draw. So if we need to do anything with draw later, we will need to actually put this inside draw. But then if we keep on redefining it inside draw, that's going to be its own problem. So I imagine what's going to happen is we're going to declare, or like do our create vector calls inside the setup function, and then we'll have some other global variable that we will just reassign to the p5.vector objects that we create here. And I assume that's going to happen somewhere in setup. But let's see, I might be reading ahead here. Okay, so now we've got two vector objects. We're ready to implement a vector algorithm for position plus velocity. So without vectors, this is what we had before. Now, all we had to do is just position plus velocity. All right. We're saving so many lines of code. Position is equal to position plus velocity. However, this is only reserved for primitive values, so we don't know how to add vector objects. Thank you, JavaScript. This isn't necessarily like a complaining about JavaScript session. That is... Okay, what am I doing defending my statements on this? Everybody makes jokes about JavaScript. All right. Let's see. There are methods for doing math. Very good. Okay, so there is a add method, but he wants to do a quick mathematical background on how vectors work. Oh, he's bringing out the fancy LaTeX kind of math. If you don't know what LaTeX is, it's basically like a math engine that allows us to write code that will render and draw out our code into math-looking words. So that allows us to do v and then a little vector thing above it, and then scalar x. So I guess a little bit of math background from what little I remember. This vector is the direction, but it's going to be considered a unit vector. So all it is it's just drawing a point in the world. And it could be like here. But the radius of this thing, or I guess the magnitude of this thing, is going to be 1. And that's kind of like what a unit vector is. I think actually unit vectors are a little bit different. Yeah, it is a pure direction. Okay, so I wasn't sure if that was a word for the specific vector of like, this is the x vector, and this is the y one, and it is always like, if it is a 0 direction in one of those things, then anyway, so yeah, this is the pure direction, so that means it doesn't really, it assumes that you have a magnitude of 1, and then the scalar is the actual magnitude. And so if you have a scalar of a number, that's how far it is, and then the vector bit is just the direction that we're looking at. Okay, so if we're doing some scalar math, sorry, not scalar math, if we're doing some vector math, we're basically doing the same thing as combining the individual components, the steps in either direction, one at a time. And so we'll notice here that the 5 here and the 3 here just combine into a 5 plus 8. And so if we were to do something like this here without like actual numbers, it is the same as, because if we were to combine this and this vector, for example, it would be the same as doing something like this. which is nice. Like if you're just like drawing the vectors on top of each other, we basically get the same thing. But we can also do the same thing by just looking at how far to the right and then how far down. I guess like in the two vector directions we go. So that's basically what's going on here. All right, and then looks like there's a few math rules that still work here, which is nice to know. All right, then we're getting to the actually juicy part of doing the math, making sure this actually works. So this is talking about if he was to make his own vector class, but since we don't have to, all we need to do is call this function. Position.add velocity. Okay, so if we were to run this thing again, this should work. And it broke. That is because this stuff isn't defined properly. So here's what we're going to do. I'm pretty sure we just want this scope to be outside of here. So we're just going to say let position exist, let velocity exist, and then we're going to reassign it to these vectors. And it is complaining because we have this bound check in here. So let's actually just get rid of this because those variables don't exist anymore. We also don't have... Okay, there we go. Position.x, position.y is why I was complaining. Basically, let's actually just make sure this works before I start trying to pretend I know what I'm doing. You gotta always back up what it is that you're saying with something that you can do, right? All right, there we go. Okay, that. Okay, we need to actually change the velocity here. Okay, so as I'm doing this, basically the things that was breaking before was we were using our old variables, but we're no longer using those variables. So now we just need to update it with the current ones. And so we know that, I guess, our velocity has a couple things going on. It has an x and y component, and so does position. And so when we add one vector, which says I'm going in the direction of 100, 100, I guess, I think this is still the x and y. And then so if we didn't have this, actually, let's see what happens if we just run position. Yeah, okay. Now let's see what happens if we just add or run velocity. I'm assuming if we just run velocity, yeah, it'll just exist over wherever that is. So these vectors are indeed just a single like point in time. Oop, I'm seeing a comment. I appreciate your appreciation. Yeah, it's been a little bit since I've done vectors too, so this is a really good refresher for me as well. Okay. So if we don't have, yeah, they're just positions, and so if we don't have something going on, whoop, then they aren't going to do anything, which is good to know. And so velocity has the x and y components, velocity being, I guess, like this is how much of a change we're going to make on each step. So yeah, I don't know why that took so long for me to kind of like internalize. If you're going a little faster in the chat, I'm sorry, you have to slow down to my speed. All right, let's see. At this stage, you might feel somewhat disappointed because it seems that it's more complicated. That's okay, because we haven't actually gotten to the cool part of this yet. And so he's just explaining all the changes that we needed to have made. All right, so what he wants us to do is he wants us to check out some of the examples that we've done before, and then separate out the x and y variables and use the vectors instead. Extend example 1.2 into 3D. Ooh, that sounds really interesting. I kind of want to just jump into this one. I'm really curious. I'm going to pop into the expected answer, and instead of reading it, I just want to see how he's... Oh, did I just download a bunch of stuff? Oh, okay. That's kind of funny. All right. I don't know that we're going to do something this complicated, but we can make it look like it's bouncing in 3D. Yeah, it's pretty rad being able to do 3D. Or just like, I don't know if it's like actually properly doing 3D or if it's actually just faking it. Um, hmm. Actually, wait, I need to see again this example. If it looks like the ball is getting bigger at some points. It looks like it is. I think he's tied the third dimension as the radius. And so that's what's giving it the illusion of popping in and out. I'm not sure what he's doing to make it so that the cube kind of rotates like this. I think he just did like some actual 3D things. I don't know. So if we look at, I guess, the papers that I showed earlier, or did I delete it? Oh, I guess I closed it. I was going to say, we could do this in a couple ways. We could do the recoding or we could do the modding. And so I feel like the way the exercise is intending us to go is to recode it. But we may just mod it because I might be lazy and Dan can't tell me what to do because I am on my own computer. Okay. I'm seeing a comment. Why does mine say it can't read undefined property? Okay, so I can't say for certain without being able to see your code, but let's see if we can troubleshoot this together. I imagine it is because you tried to do something like this. Let's just see real quick if this results in the property problem. Reference error not defined. That's not the same error that you have. So I'm assuming it's not because you tried to call create vector outside of setup or draw. Okay, so my next thought is that the property problem is that it is complaining about you trying to access something like a attribute that doesn't exist necessarily. No. Okay, Z showed up. I forgot that Z is totally a viable thing. Okay, so then expecting a number for the first parameter, but received an empty variable instead. That is an unrelated problem. So if I just did position dots happy dot potato, I don't think potato is going to exist. It doesn't actually complain. Instead saw an expression. Okay, I can't figure out how to get to the undefined property add. Oh, you're talking about this one right here. Okay, so position.add. Let's see what happens if we try running it out here. Okay, I'm assuming you're having this problem. The fix to it, I think, would be to move it inside the function draw or setup, because for some reason vectors can't really exist outside of those two functions. That is my proposal for that fix. Do let me know in chat if that is something that helps you or not. I would just try to make sure that anytime you do any sort of vector related thing, that it exists inside of draw or setup. And so any variables that you have associated with those things that need to be in both, for example, are defined outside and just assigned inside of one of these functions. Good luck and let me know how that goes. Otherwise, let's try to figure out how to recreate this bouncing ball. So I think the first thing we're going to want to do is we're going to want to set an initial radius size. So let's just expand this out to be like that. So now we should have access to... Okay, I'm seeing an update here. Nope, mine is in draw. Okay, where is your position defined? Is it defined in draw or setup? And where do you call your create vector? Is it set up similarly to mine? Okay, while I wait for you to respond, copying the exact same thing from the sites does not give you the error. Could it be that there's a typo in the attribute that you attached it to? Like maybe you typed in positron? No. It would have complained about something else. I don't know. Yeah, I'm sorry I can't help you. Okay, well the good news is that you could always copy it from the site if you want to catch up. You can also just like see if there's like pay extra attention, I guess, to see if there's any differences in my code versus your code. Here, let me share this file with you. I guess like with everybody. I'll drop it in chat. Just keep in mind that you'll need to refresh the page, I guess like whenever something happens or whenever I do something here. See, I'm not actually able to do a thread inside the announcements channel, so I'm just going to reply to myself. It's going to be also in the Discord. You see the problem? Okay, what's the problem? Ah, yeah. No, that's... I'm glad you're able to figure that out. The whole variable declaration thing is kind of annoying. I always forget how to do global variables in JavaScript without just moving it outside of these functions. It's a little annoying. Anyway. Okay, so this is going off of zero documentation, but just like off of just like pure reasoning, I guess we're going to try to go for reasoning. We're going to take this and then we're going to change the position dot z is less than, let's just do height as well. Position dot y, nope, to position dot z is less than 0. Then we will change velocity. Z is equal to velocity dot z. And then we flip it in the other direction. And I think, let's change this to be position dot z. Let's actually change this initial thing to be 50. Nice even number. And then let's make this a little bit more dramatic of a change. So it'll be about 10. So in theory, we should start with an initial size of 50 pixels. That's how big our circle should be. And then we should be, when we add the velocity, making it go bigger. And then when we hit the bounds of it being, actually height might be a little too big because that's gonna be a really big circle. It would probably be pretty funny though, so I'm gonna leave this as is. And then when it goes the other way where it looks like it's just going to disappear, then it's going to switch, and then the velocity is going to speed up again. Let's actually, let's see, velocity of 10. Oh, it's not going to be changing too fast, but let's just see what happens. Yeah, okay, there it is. Yo, it's really big. Okay, let's change this height to be something a little more reasonable. Okay, now that's really fast. So let's actually change this to like 1. Okay, let's change the minimum size to be, I think, like 10 is a pretty reasonable. Okay, okay, there we go. It's kind of like a dribbling kind of vibe, kind of like a booger kind of thing running around. I'm gonna make this a little bit bigger actually. Let's make this 20. I don't like how it gets to the stage where the ball is like the same size as like the stroke. That makes it look kind of strange. Okay, so that's not quite as fancy as the problem that we had here, but I think we've done enough recoding, I guess like re-engineering. No, we didn't do really much re-engineering. We're modding our previous example. So now let's actually take a peek at how he did it here. How our boy. Oh, this isn't actually Dan. This is Wendy Duran. I don't know if I got her name right. Wendy, if you ever see this stream, please correct me. um, all right, so let's see what it is that we did here. So he created a new ball object. I'm assuming that means that there's another ball file. Yeah, there we go. Okay, let's just see how it's used before we explore how the ball was defined. We've got the background, starts at the very top, which allows us to draw the background before we draw any other images on top of it. We take advantage of orbit control, so apparently that's just something we can just add. I want to see real quick if we can just do that right here. Orbit control. And then do we need to do anything? Okay, so we're not in WebGL mode, so we're not able to take advantage of this. I wonder if there's a really easy way to just add in WebGL mode. Let's see, maybe that's handled under ball.js. I'm not seeing anything that says anything about WebGL mode here. So that's unfortunate. There's probably something underneath the reference right here. Whoa, nice. Oh, looks like we just need to add it to the canvas right here. WebGL. Okay, so that's. Thank you. Oh, sorry. I just saw your comment. Sorry. I'm glad that you were able to see that before I did. Okay. Yeah, that is really entertaining. I want to leave that there. I think that's very funny. All right. Let's see how else this thing works. So he made it so that I'm assuming this thing is related to the box controls and just changing the speed at which we rotate. So then he also has a separate function that's, or Wendy does, that creates the box size and makes sure that it stays within the bounds. And then, let's see, print instructions to the canvas. Okay, so this is just the text part of the thing. And then so if we poke around into ball.js, let's collapse these things until we can see only one thing at a time. We created all of these wonderful things. Then we set the radius to be 10. Cool. Update is just adding the velocity. That makes sense. Checking edges. So this is just bounds checking. Okay, cool. Honestly, if I were to write this, I would probably actually extract this out and then make like a variable for these things, because I think that's a little bit more readable. Um, I know I was too lazy to do it here, so I'm gonna change this to demonstrate what it is that I would do as far as clean coding goes. I don't know if this is like best practice at all, but I think it helps me a lot to be able to list this out as its own variable. So I would say x upper bound maybe, or upper, we'll just call it upper. And then I would extract this out to say position dot width, and then it would be more like x upper, or it'd be x lower, x lower. Yeah, and then so I would do something like that. I think that's a little bit easier to read personally, because then you have the exact actually the name of the condition that you're checking, and then you're just comparing those things. And then if we wanted to take this a step further, you could also, I guess, extract this into its own like function as well. Or sorry, yeah, you could extract this into its own function, but since this is a really simple update function, like you can just leave it as is. It's the way that you can also go about that. But yeah, besides that, I'm not. This is not a code review session. Okay, so the next thing is push. I don't know what this push is. Let's actually see what this push is. P5 reference P5 push. Fill and transformations are applied to all that follows. Push and pop limits, transformations, yada yada yada. So it can be used to create subgroups. Do we have an example? Push, begin the drawing subgroup. Pop, end the drawing subgroup. Oh, so this is a way to organize things. Ah, you've been Googling a lot. Push saves the current drawing state, including transformations and styles like fill and stroke, according to Google. Awesome. Thank you for helping me search this up. For the person who asked in chat previously about like how to learn how to code, this is like the proper way to, or I guess it's not so much of a proper way, but this is like one of the ways that you could kind of take advantage of using and balancing documentation with all these things. But yeah, anyway, I think I've had my fill of that, so let's hop back over here. And we've done that. Oh, he wanted us to actually put this in a box. I don't know that I am willing to put in the time for that. No, our friend is just bouncing all over the place. Okay. We have a question. Currently in your third semester, but first year completely wasted trying to figure out how to survive like college. I'm confused if I still have time to start my coding and DSA journey, or I am way too late for this. I don't think you are ever going to be too late. Well, I guess it depends on what it is that you're trying to get out of your coding and DSA journey. If you're planning on doing a career transition, I'm assuming you're not in a computer science program from the way that you're describing this. And I don't know if this is in college or in high school. So it's a little bit different depending on what you're talking about there. I don't think it's ever too late unless you're planning on doing an interview like next week and you're just starting to code. That might be a bit tough. Likewise, if you're applying to university, well, actually, applying for university, you don't even have to have like computer science backgrounds to apply into a computer science program. I didn't really start coding until I started college, and I ended up taking the, I guess, like very intro to intro like computer science classes when I was there. They did technically have like a fast track, like if you've done programming before, take this class, because it goes through the same amount of contents, but I guess like in 1 quarter instead of 2 quarters is how my university had done it. But yeah, if you are looking to learn how to code because you want to transition into a career like this, then really you should be trying to do this before you graduate and like are looking for like full-time employment. And one of the best ways to demonstrate that you've got a mastery of like programming like enough to the stage where you would be productive in a work environment is to have projects that you could use to showcase what it is that you're capable of doing. Because the university degree in computer science is just like it's it is a thing to represent all of your previous studies, right? And so the thing to represent your understanding of computer science is with projects. The nice thing is that with projects, you have access to a lot of AI tooling now and like infinite tutorials that you can find. Most of which would look more impressive if you found ways to make it your own and adapt it in a way that it looks like it wasn't just you following a project, as far as like job search goes. But yeah, feel free to I guess like add in more context to what your situation is as far as surviving college and I guess like starting your computer science journey. You are in the right space to be, I guess, like building and learning how to do these things. GHWs are a fantastic way to get started in learning, and just being, I guess, like getting exposure to the different worlds around computer science. I am sorry to hear that your first year was a complete waste, though. I think my first year was also kind of like quote unquote wasted. I wouldn't say it's necessarily a waste because learning what was productive for your journey in your first year, I think, is still a very relevant thing, as long as you don't fall into the same trap as you did your first year in your second year. Um, even though I like started learning computer science in my first year, I also started getting involved in clubs in my first year, but I committed to way too many because I was really indecisive about what it is that I wanted to do, and I didn't end up having anything to show for it in my first year. And so I felt like I didn't really spend my time in a very useful way. But the good news is that now I know that being all over the place is not productive for the way that I live. And so I guess being everywhere at the same time and like having like some amount of decisiveness was an important lesson for me to learn. Um, so yeah, don't mark it off as a waste. Just figure out how to move forward and continue improving. As long as you are a better person than you were yesterday, we are moving in the right direction. Okay, sorry for that sappy side tangents. I appreciate the questions. Feel free to ask more in chat if you need it. I'm going to hop back over to the code thing. Let's see. He really wants us to bounce around in a box. I think this is honestly box enough. I guess that we could do is we could try adding in, let's see. Actually, wait, I'm curious about how the sphere ended up actually bouncing around in different directions. Did we add a third vector? No, we didn't. We need to address this in all dimensions. This stop position is less than the box size, minus the radius to make sure the ball is fully inside the box. Okay. And then, yeah, we ended up doing the velocity in the same way. It's just that we added in, we used translate instead of just the circle definition. And then we gave the sphere a thing. So I wonder if we could do this really easily. I wonder if we can just do translate this dot position dots x position dot y, this dot position dot z or z, and then we add in the sphere. We don't actually have a radius, so we're just going to set this to 10. Well, let's see what happens. And we broke everything. Because this dot position is undefined, that is correct. We didn't actually have a this. So it would just be a position. Okay, and the ball is bouncing off into eternity. And I saw it for a quick frame. Okay, so we finally rotated it in a way where we can actually see it. Okay, cool. We kind of, I mean, we just didn't draw a box. I don't really want to draw a 3D box right now. But if you in the chat wanted to draw a 3D box, go for it. All right. Let's see if we can get to the halfway mark before this stream ends. We've got about 23 minutes left. So let's see how far we can get. Okay, so we can see we have access to a bunch of different other kinds of math. Subtraction, multiplication, division, magnitude, lerp. Lerping is fun. Lerping is very fun. If you don't know what lerping is, basically it is a math function that allows us to do this thing that's called interpolation. And interpolation is basically the math between two different points that kind of like smooths it out. And so right now we've been doing things in kind of like a linear way where it's just like add velocity, add velocity, add velocity. Lerping would kind of smooth it so that it isn't just add velocity. It's like add velocity, but like a fraction of that velocity until it kind of like ramps up. And so if we take a look at the lerp function, p5 lerp, you can see how it kind of like the ball just kind of like bounces to where my mouse is, and then it just kind of like smoothly goes back to where the other place is. That's what the lerp is responsible for. Those aren't the examples I was hoping for, but I hope you get what it is I'm trying to say there. Okay, there's a few other important ones, especially if you're like a machine learning kind of person. There's the dot and cross products, our favorite vector operations, maybe. I don't know. I'm a real big fan of the simpler addition and subtraction, but you get access to a lot of other cool things. Oh, it looks like we can also choose a random direction in 2D and 3D. So if we wanted to, we could make a random walker that walks using vectors by using that function instead of individually changing like the randomness of like each individual component, which is pretty handy. All right, subtraction is just mirroring and flipping it in the opposite direction. So we can see, I guess, like where it would go instead. And so that is as simple as just normal subtraction. Whoa. Okay, that is actually really cool. So from my understanding, this is taking the two shadow vectors and then just drawing a more direct line in between. Or maybe it's doing a different way. Hang on, I just disconnected my charger. I'm gonna reconnect that. Oh, I'm changing the wrong one. All right, there we go. We're back in business. Okay, let's see. So this is going to be a new project, so I'm going to go ahead and make a new project. So now we've got this. Let's change our backgrounds to be. We had a mustard kind of color earlier. Let's see if we can get like a more bluish hue. So R, G, and B. So maybe 100. G's next. So we'll do 100, 100, and then a bluish. I want something a little bit nicer. Let's. I like that blue. I think that blue is pretty nice. Okay, so let's keep going. We've got let mouse is equal to create vector, mouse x, mouse y, mouse center is equal to create vector, width divide by 2, height divide by 2. All right, and then we can do this, stroke 200. That's a pretty thick stroke. No, wait, that's just the color. This has only got a thickness of 4 pixels. When in doubt, I like to use 4 pixels. I don't know why. It just feels like the right size. I use that in Google Slides a lot. Okay, and then now it's time for us to do subcenter stroke 0. Translate width 2, height 2, line 0, 0, mouse dot x, mouse dot y. I'm wondering why. Oh, right, that is the vector. So we just define the vector, set that to be wherever the current mouse direction is. And oh, it's complaining about us using the word center. Okay, let's just call this middle then. I don't want to upset P5. That would be sad. Okay, so we now have the same thing that the example had. I kind of want to add alert function just because it's kind of funny. But I also want to stay on topic. Oh, nice. Okay, so the rest of these examples are just kind of going through how these work. If I was feeling particularly inspired, we could make like a little flipper thing. Maybe if we were designing like kind of like a math tool for describing how vectors work for students to use in the classroom, I would do that. But our goal is not to build tools right now for classrooms. That is something that is a personal interest of mine. Let's instead focus on actually getting to the examples here. Okay, so he does a breakdown on matrix multiplication, vector magnitude, which is figuring out how much something is moving. Oh. And so in this example, I'm pretty sure he's just doing, let's see, for this top bar, the top bar is probably some sort of range. No. Where is it? Where's your line? Ah, there's the rectangle. Okay, so this is the magnitude. And then the line, actual vector is right there. Okay, there we go. I don't know why I was thinking that it necessarily had like a 100% thing. Yeah, because as soon as it goes off to the right side of the screen, let's see. I don't know if we can tell if this canvas element actually doesn't even start over here. Yeah. Okay, so the thing I was going to point out was that this rectangle doesn't actually start on the leftmost side. And so I was checking to see if he made it so that this thing stopped at 100 or not, because there's another function that he really that Dan Shipman likes to use a lot, which is called, is it range? No, it's map. It's map. And so the way that map works in P5 is it remaps a value from the initial range, which is the first two numbers. Actually, no, it maps the initial range, which is the second and third number, with the fourth and fifth number, and then this first number is moved. This first number is a number that's usually between this range right here, and then it gets remaps to be a number from here to here. So this stage, this was like 20% of the way through the original range, which would mean this thing is now going to be 20% through the way of this one. Yeah, so that's what I thought he was going to be doing there. Turns out he didn't. You can see because like on the very edge of this pixel, it just kind of goes off the edge. So you didn't really need to worry about that. Anyway, that was more of a side tangent than it should have been. Okay, let's go back to this. Normalizing vectors, this is where you get it back to the unit vector or the unit length. So we separate out the magnitude and just get a pure kind of direction. Okay, so that's that situation. And then there's some math around that. We're not going to worry about that because there are some clever people who have already figured out how to do that. And it looks like the easy way to do that is to just do that math, which is basically just taking the, getting the magnitude and then dividing the magnitude. Yeah. So yeah, that's the unit length version of that thing. Motion with vectors. Oh my gosh. Oh. All right. Sorry, everybody. I just needed to really get that yawn out. What does it mean to program motion by vectors? We got a taste of it with the bouncing ball. All right, that is true. These steps are motion 101. We add the velocity to the position, and then we draw the object at that position. Okay, that makes sense. We can see that we've now, let's see. What I want to do now is move towards encapsulating the logic inside a class, which is pretty similar to how Wendy had done it in the other example we were looking at. And then so brings up the chapter 0 random walker that we had previously built. We're going to be instead building a mover class that moves around. So then there's two things we're looking to do here: to define a class, that is, what information does it have and what can it do. So the information that we have is velocity and direction, which are velocity objects. Okay, and then we will have, as far as things to do, just like a movement thing. And so this is very much following the pattern that we saw in Wendy's example earlier. Let's see. Oh. Okay, so this is all something that we could technically do without having a mover class. W vector thing, vector practice, vector math practice. So let's go ahead and make a new page. I'm going to call this GHW vector mover. I actually rather enjoyed this background color from before, so we're going to see if we can recreate it. I think these were the numbers that we had before. Yeah, I want to make it blue in the other direction though. Let's see. Oh, that just makes it purple. All right, that's fine. We'll roll off of purple. Okay. So let's go ahead and start making this mover class. So this mover class is probably going to exist in another file. I think last time we did this, I made a new file manually by going here and here. I think there's actually a way for us to do this here. Yeah, there we go. So we're going to use this, and then this should actually handle the linking inside HTML for us. So we're going to go ahead and try doing that. We've got, I'm going to call this just mover. Maybe capital mover.js. Let's see if that actually adds this in here. Sag. Okay, it did not. So I'm gonna actually just rename this mover.js. I feel like that fits the vibe a little bit more. All right, we're gonna do class mover. Build our constructor. This dot position is equal to create vector. Looks like we're doing a random direction, so looks like we're making our random walker like we did last time, just with vectors. Okay, and then as far as randomness goes, we're going to be putting this within the range of -2 to 2 instead of heights to width to height. That makes sense for velocity, since if we made it scale to the height and width, that would be a very, very fast ball. We wouldn't be able to see it because it'd be taking the entire distance of. Anyway, okay. So we've got our constructor built. We know that our update is just going to be a little math thing. This dot position dot add this dot velocity. I think, yep, that's pretty much it. All right. And then we've got the show. So this means this is going to be the part where we draw out what it's going to look like. So it looks like we're going with a stroke color of black. But I don't like that, so we're going to actually change this to be 255. We're going to make the fill, that would be like a gray circle. I think, let's try doing the blue color that we had before, now that I've memorized the RGB code for that. And it looks like we're going back to our lovely circle of size 48. Okay, check edges. This dot position dot x. And then this is a copy pasta for the y. Okay. Cool. That looks mostly like it. Now we actually need to pop this and connect this with the rest of our app, or I guess our website thing going on here. So what I'm going to do is I'm going to make sure that this mover script is called before our sketch script, because sketch.js relies on things from mover.js. And we're not playing around with JavaScript modules, so we're just going to do this. And now our JavaScript, whenever it pops up in the HTML, should be able to access all of the things inside mover first. And so now if we were to just do let mover exist, and then assign mover to be new mover, Well, I guess we don't need to do those shenanigans because we know that movers should exist. That's here now because we're defining ourselves, so it's no longer attached to just the context of setup and draw. Now we should be able to pop in here and do mover.update, mover.check edges, mover.show. Okay, so let me check real quick. Check edges. If that changes, oh, right. This is just assigning the position, so we're no longer doing the bouncing ball thing. And so it's basically just resetting the position to kind of stripe along, run this kind of like infinite planet kind of thing. Oh, okay. Looks like we're getting some hands thrown. Let's see what's going on here. Can't access lexical declaration before initialization. I'm assuming that's because the things that happen here don't necessarily happen before draw. So let's just try doing this. Let's see if that fixes the problem. Oh, there we go. Okay, so now we've got a little slow moving thing going on here. I think that's awfully slow, so I'm going to see if we can make this a little faster. And we know that we can make it faster by popping into velocity. And let's see. I think the vector that's being created happens once per initialization. So if we actually run this again, it might actually even just run faster. There we go. Yeah. So this is, it only happens once per initialization of mover. That's why it's, and it's somewhere between -2 and 2. That's why it's moving the way it is. Okay, so if we had wanted to make it faster instead of like deterministically, we wouldn't have to worry about that. Oh my word. We are at time. Okay, so let me keep track of where we are right now. We are at example 1.7. We will continue from here the next time. Thank you so much for dropping by. Looks like there is going to be a chat with GitHub. Sid Harth has noted things there. Feel free to take a poke at where is it? I think it's mlh.link/GHW feedback. If there's anything that you want to see me do more of, do less of, etc., feel free to toss that in chat. Thank you so much for the love. I appreciate you. I'm looking forward to seeing you all tomorrow. But for now, so long and enjoy the conversation with Swift and GitHub. Take care, everybody. Bye-bye.